Okay, everybody, good evening. Nice to see you. Welcome to the first session of the new session. I don't think, I need to do some housekeeping things apparently. So the fire evacuation procedures, this doesn't apply to you, Rebecca. We're not expecting a fire test. There will be a very loud noise that happens, in which case you basically have to make a dignified exit through the nearest fire exit door. Try to stay calm and please don't use the lifts. Okay, and then I guess you gather outside at the assembly point in front of the building. Okay, so that's that done. Okay, so without further ado, this evening our speaker is, I think, comfortably at home. Down in the southwest, and so we'll be seeing her on the screen here. Our speaker, Rebecca Paisley, is going to be talking about lithium this evening, and she's the lead geochemist for Cornish Lithium. And she's got a PhD in Earth and Planetary Science from McGill University in Canada and a master's degree in Earth Sciences from the University of Oxford, and specialises in geochemical data to constrain subsurface processes in a variety of geological environments. She joined Cornish Lithium to assist with developing the geochemical side of their exploration efforts, and currently designs and implements the geothermal water sampling strategies for their drilling programs. She also manages Cornish Lithium's direct lithium extraction work package, evaluating different technologies and their abilities to process Cornish geothermal fluids. So I'm sure we'll be hearing a lot about all of that this evening. So Rebecca, hopefully this will run smoothly, but the floor is now yours, so welcome.
Great, thanks for having me. Can everyone hear me okay?
Over there. Yeah.
Sun silence says yes. Thanks for inviting me today. And I am going to talk a little bit, obviously, about lithium, about Cornish Lithium and what we're doing here in the southwest. And got a chance to answer any questions towards the end. And happy to talk about kind of anything geology, really. So without further ado, because this is a company presentation, I have a company disclaimer, which we're going to slide over immediately and go straight to the big picture. Why is everyone suddenly talking about lithium and all of these other rarer metals? And ultimately, it's because we are in a climate crisis. Carbon dioxide levels are the highest they've been in the last 3 million years, and the world was a very different place 3 million years ago. And if we are to at least attempt to reach the Paris goals from the most recent agreement, we need to reduce the amount of CO2 that we're putting into the atmosphere from anthropogenic means. And in order to do this, we need to mitigate or reduce the instruments and kit and everything that produces CO2. So we're talking obviously fossil fuel based transport and fossil fuels for energy. And so that brings us on to this energy transition, which people are talking about. What actually is involved in this energy transition? Well, it's transitioning to technologies that aren't as dependent or utilize fossil fuels in the same way that our current processes do. And so those kind of low carbon technologies, that includes wind turbines, solar panels, and obviously batteries for lithium batteries for electric vehicles and energy storage and so on. But obviously there's no tree out there with solar panels growing on it. We produce and build these materials and these equipments from stuff that we grow out the ground. And so if we're going to have an energy transition, if we're going to use these low carbon technologies, we are going to need more mining in order to meet the demand for different metals that will be going into these techs. If we just dive into a couple of these different technologies, have a quick look at wind turbines, for example. You have over 1,200 tons of concrete in a single 3 megawatt wind turbine. And wind turbines are increasing in size and capacity all the time. And so this will only ever increase. You have 4 or 5 tons of copper in each wind turbine, 2 to 3 tons of rare earth elements. And that's just a single wind turbine. And we're looking at having a significant percentage of the UK's energy grid being powered by said turbines. If we then look a little bit at solar panels, they're becoming more and more efficient with the years, and they're starting to be used for energy production as well as heating. But 70% of that surface of that solar panel is made of glass, is made of silicon dioxide. You've got tin, silver, lead in there. You've even got polymers, which are actually hydrocarbons. So as we look to build more and more of these objects, we're going to need more and more of these materials. And obviously, batteries is the big driver for lithium in my part of the industry, at least. Lithium-ion batteries are becoming the center of the new vehicles, and as we transition to going to have solely electric vehicles being sold in 2030, 2035, depending on each country, we're going to need a significant amount of lithium. Each car battery can have anywhere between 10 and 50 kilograms of lithium. The UK produces over 1 million cars a year. Europe produces about 18, 19 million, and over 90 million cars are made globally. So you can quickly see, as we go from producing combustion engine vehicles to electric vehicles, that demand is going to rapidly increase. And so all of these low carbon technologies are leading to a increased diversity in the types of metals that we're trying to find. Whilst this talk is obviously going to focus predominantly on lithium, if we take copper, for example, we're going to need to mine the equivalent amount of copper that we've mined in all of human history in the next 25 years in order to meet the demand required from this transition into low carbon technologies and building all of these wind turbines and solar panels and so on. But obviously I'm here to talk a little about lithium today. So why are we needing lithium in the UK? Well, obviously we have an automotive industry. It is one of the biggest industries in the UK, hires over 800,000 people directly or indirectly. So that is, at least 1% of the population of the UK. But we don't have any battery manufacturing in the UK. We don't have any lithium manufacturing or other metals. And so when 2030 comes and we have to be producing electric vehicles in the UK, we want to have been able to capture that value chain all the way up to producing those vehicles in order to remain competitive on the global stage. This is partly driven by the rules of origin that have come in since Brexit, that if a certain percentage of the vehicle or any commodity you're making in the UK is produced or built from materials that haven't originated in the UK, they add an export tariff onto it. And so in order to remain competitive, when you're selling cars abroad, you need to make sure that those tariffs aren't placed on your vehicles, which goes back to making sure that everything that comes out from the vehicle into the vehicle, as much of it as possible, comes from the UK itself. And that is leading to the Faraday Institution, don't know what's happened there, institution suggesting that we're going to need over 135,000 tonne per annum LCE, so lithium carbonate equivalent, by 2040. That's more than the globe currently produces every year. And that's for the UK alone. And by 2025, which is just a couple of short years away, the demand for lithium is expected to outstrip the supply. So why are we talking about lithium? For batteries at least, lithium is the most energy dense battery energy dense element, sorry, it sits right at the top of the periodic table. And whilst it's an abundant element across the planet, it's rarely found actually in economic quantities. So is it economic to mine it out? Currently, there are a whole host of ESG issues regarding the current production of lithium, be it the high carbon in the processing or the land use and water use during extraction in Chile and so on. And as we increase that demand for lithium, those ESG issues are only ever going to grow. It takes at least 10 years to go from finding a project to actually developing a project. So that lithium that we're going to need in 2030 would have been needed to have been found about 2 to 3 years ago. And that's all down to the financing of these projects and the permitting of these projects. And then we find ourselves in an emerging industry. So there are challenges in just processing the materials to make the chemicals that are needed for batteries in the quantities that they're going to be needed, but also the specific chemistries. Impurities can affect how batteries perform. And so we need to be able to remove those impurities from the products that we make. So I'm going to assume that everyone in the audience today has at least a mobile phone or a smartwatch, electric vehicle maybe. So where is that lithium in those objects come from? Well, at the moment, the majority of lithium is either produced in Australia from a hard rock material known as spodumene. So this is an aluminum silicate, or it's produced from the South America and the lithium triangle. And in South America, it predominantly comes from, or exclusively comes from, brines. So these are really salty, lithium-rich waters that are pumped to the surface and left in evaporation ponds for close to 2 years to evaporate off the water, concentrate the brines up, and then they're processed for lithium and also other elements like potash. So as you can see, or you can envision, those kind of projects require a lot of land because they need to leave the water at the surface for a very long time. And then you've got the problems on the Australian side, where spodumene is a mineral that needs to be roasted to over 1,000 degrees in order to break it down enough for the lithium to be released. So the current flow sheet, if we were to take some brine from Chile, is that you would produce a lithium carbonate in South America, and then it would be shipped to the US or Southeast Asia for refining. Then it's made into batteries, or into cathodes that go into batteries that then go into your vehicles that then go to the customer. If we were taking lithium from Australia, that first step would actually be it being concentrated in Australia, but actually then shipped to China in order to be processed into a chemical that can actually go into a cathode and into a battery pack. So overall, the lithium that's travelled in your electric vehicle and your phone has probably travelled about 50,000 kilometres before you picked it up from the store, or it was sent to your house by Amazon and other means. But the UK and Europe are looking to domesticate those supply chains. And what I mean by that is, how do we bring that production of not just the raw materials, but also the intermediate products into the UK, into Europe, in order to reduce the risk and dependency on the geopolitical side of things. So, being dependent on other countries, being dependent on high risk supply chains, and also to capture the value chain. So if you can produce the raw materials and refine them, and then build the batteries within your own country, you are far less dependent on China and Asian markets, but also you can retain the industry within your country, hire more people, and create more skilled jobs. So that is what we as Cornish Lithium are hoping to be a part of in the UK. And who are Cornish Lithium? So we are currently a privately funded company. We've been around since 2016. Our founding It was founded by Jeremy Raffle, who is our CEO and remains the CEO to this day. And whilst we were a small company just a couple of years ago, we're now over 60 employees. We have two major projects, which I'll go into a bit more detail towards the end of my presentation. But we have a hard rock project. This is known as the Trelava project, and this is based in St Austell. And this is more of a traditional mining project, so it's a hard rock project. And then we have our lithium and geothermal waters project. This is what I work on. And this is very much an innovative and unconventional resource that we're looking to access across the southwest. So why are we Cornish Lithium and why are we focused in the southwest? Well, three main reasons for focusing on Cornwall. The first is obviously going to be the geology. So Cornwall is underlain by a lithium enriched granite. It extends all the way from the Isles of Scilly all the way up to Dartmoor. That's why the Isles of Scilly are an island, and Dartmoor is very hilly. It's exposed at 5 locations on the mainland. We've got Land's End, Carmen Ellis, Bodmin, St Austell and Dartmoor. And this granite itself is enriched with lithium, and it's also divided into 5 subsets of granite. The last 2 that came in and intruded into the area, the G4 and G5 granites, are the most evolved, the most lithium enriched, and that's why our hard rock project is based at St Austell, because that's where these G4, G5 granites crop en masse. Cornwall has a huge amount of mining heritage, over 3,000 known mines in Cornwall, 4,000, 5,000 years of mining history. And most of that has been focused on the base metals found in Cornwall. So your copper, your tin, lead, zinc, tungsten, and so on. We are interested in those base metals as well, but a lot of the information from that historic period of mining in Cornwall actually aids our exploration today. And finally, particularly for the water side of the business, we're interested in Cornwall because of the elevated geothermal gradient. So in Cornwall, because the granite has a huge amount of uranium, thorium, and potassium, the geothermal gradient in the area can be up to 40 degrees per kilometre. That's significantly higher than anywhere else in the UK, and it means that when you start to drill to 1 to 2 kilometres, you can be producing waters from that depth that could be easily 75 degrees. And that aids in the processing, but also aids in the water rock interactions that are breaking down the rocks in the subsurface and releasing the lithium in the first place. So second main reason for looking at Cornwall is that existing infrastructure from the old or older or reduced industries down here. So the China clay industry, for example, was one of the biggest employers in the area, and still goes to this day, but is in decline, particularly in the last decade or two. You have infrastructure from the kind of mines in the late 90s. We're talking roads, railways, and so on. So we can utilise some of that. Cornwall is somewhat accessible to the rest of the UK. We've also got underutilised industrial areas. So we have a lot of areas where we can build our refining plants and so on without having to use greenfield sites. And finally, the renewable energy potential in Cornwall is significant. There is a lot of onshore and offshore wind, as well as solar panels down here, which we can potentially exploit for our refining plants. And finally, Cornwall has a huge heritage related and associated with mining. There is a huge demand for jobs down here that are stable, not seasonal, not dependent on tourists and tourism industry. That's become particularly obvious in the last couple of years with COVID and travel restrictions and so on. Because the last mine in Cornwall only closed in 1998, there is still a lot of mining knowledge within the communities down here, and mining skills, which we can hopefully, what we plan and are utilising within our exploration and extraction and production and so on. And so it really is a great place to try and bring a new industry back. So 21st century exploration, how do we go from old mining to new mining? So I'm going to talk a little bit about some of the work that our technical team does, and it all starts with our archive team. So as I mentioned, we have the richest square mile in the world, for example, was once in Cornwall, and that's just because of the copper and tin mining in the area. And so we're utilising all of those old maps, mine maps from the 1800s, 1900s and so on, to create different models of the subsurface, but also to understand who owns the land rights, who owns the mineral rights in different areas. And we can use that again to understand what was actually happening in the mines in the 1800s. Were they finding that water was pouring into the mines from fractures? Were they getting particular mineralization in particular areas? And all of this feeds into our exploration team for the generation of new sites, and also reduces our field exploration costs because we can do a significant depth study before we go out to try and target particular structures. So how do we do this? So we take those digital maps, or these old maps, and we digitize them. And then when you start to do this in 3 dimensions, you then create these 3D digital models. So this example here, the grey lines are onsets of faults, and then the blue, yellow, and so on are different trending faults. And we've generated this just from old mine maps. But we can do this across Cornwall, particularly in more heavily mined areas. But we don't just use historic data, we also use modern data. This can come from satellite data, bathymetry, and so on. And we use this primarily to understand and follow structures, so fault zones, across the county. We collate this together with our 3D maps and some very smart machine learning, which is way above my head, to bring together these models. It also helps us understand the land use, and also look for alteration and various things that is a lot harder to see in the field when you're right next to it. We can then collate that with aerial surveys. So we can do EM surveys and all sorts. And we can also use drones. So in Cornwall, for those of you who haven't been, there is not a lot of exposed rock in Cornwall. It's predominantly farmland and so on. And so you only really get the exposures of rock when you go to the coasts. And it's not particularly safe to abseil down these cliffs to take your strike and dip measurements or to understand the faults and so on. And so we can use drones to take thousands and thousands of photos. We can stitch these photos together into digital elevation models, and that then allows us to do our field work but in virtual reality. So we can then take that information that we get from the coast, interpolate it inwards, and integrate that into our models from our satellite data and also from our historic records. We then bring in geochemistry data from different sources. So you have your water data, which we can use to understand water-rock interaction, the ages of different waters, whether waters in certain areas are similar to each other or different. That allows us to understand where we should be targeting. We can get this water from surface springs, but also from our drill programs. And then we also can use geochemistry from the soils and the sediments at the surface to understand the subsurface geology that you can't easily see. And then we can also use the geochemistry of the rocks that we bring up from our drill core to understand how the granite or the metasediments and the host rocks are varying with depth. And sometimes we actually get to go and do real field work as well. And because Cornwall can be sunny, sometimes it's really not a chore at all to go out, look at the rocks, and gather a lot of data and verify a lot of our, particularly our aerial surveys and so on. So that's a bit about what we do within the technical team to build these projects up from scratch. and now I can give you a little bit of an update about what those two projects are in detail and how we plan on going from exploration into production. So the first project I'm going to talk about is our Trelava project. This is our hard rock project. This project is focusing on reopening an existing china clay pit that's been shut for about 10 to 12 years now, and reopen it to mine for lithium rather than to mine for china clay. So china clay is a mineral, it's kaolinite, it's an altered plagioclase, and the granites in this area, when you've removed the china clay, you have the mica minerals remain, they haven't been altered. And so the mica minerals are hosting the lithium in high quantities, and that's what we would be looking to exploit when we reopen the pits. We recently released a JORC compliant resource for this project, and the feasibility study is underway, so that will be refined in the coming 12 to 18 months or so. We're looking at producing, equivalent to about 300,000 tonnes per annum, 300,000 tonnes, sorry, of LCE across this one pit. What we are targeting is production in early 2026. What that means for our timeline is that the feasibility study is underway. They are designing small demonstration plants for the two parts of the process, which I'm going to talk about in a sec, the extraction process. They're doing more drilling to refine that resource estimate, and then we go into full-scale construction of the plant in 2024 and 2025. So the process that we're looking at is, how do I take granite and I turn it into a battery-grade hydroxide? Well, the first step is I need to remove the other minerals that aren't the micas. So it goes through a traditional physical processing flow sheet of crushing and grinding, flotating, sometimes using magnetic separation to remove the micas from all of the other minerals in there. And then it goes into a hydromet process. We have an exclusive license for process from a company called Lepidigo, who are an Australian-based company. We can use their technology exclusively across the St Austell region. This uses acids primarily to break down those micas and turn it into an intermediate lithium product that we can then convert into battery-grade hydroxide or battery-grade carbonate. What's great about this process is it doesn't use high-temperature roasting. So from that point of view, it has a reduced carbon impact compared to the production of lithium from spodumene. We have successfully operated a plant off-site in Australia, and now they're looking at bringing that over here and doing demonstrations over here. We produce battery-grade hydroxide from that process, over 90% recovery. And what's really interesting about this process is actually you can produce a whole host of other co-products, rubidium, cesium, potash, but also aggregate and some silicon products as well. And what that means is you improve the economics of your project, and you're really exploiting everything that you're digging out of the ground. So reducing those tailings in that sense. And so that is the timeline and targets for that project. And then we've got our geothermal waters program. This is what I largely focus on. And what we are doing on this side of the business is we're targeting fault zones. So rather than looking for the granite in the subsurface, we're interested in the fractures, the faults that cross-cut the county that are highly permeable. So that's when we start to use a lot more of that archive data that I talked about previously. So far, we've drilled 3 research boreholes, so 3 exploration projects, and we have another half a dozen that we plan to start in the next couple of years. And all of these have particular structures that we're trying to target with these boreholes to prove that they're there, and then extract the lithium waters from them. What's so great about the waters in Cornwall is they are lithium rich, but there's a lot fewer elements in there that are known as deleterious elements, so elements that can be bad for batteries like magnesium, and also elements that can be bad for the extraction process, so your sulfates, your calciums, and so on. what we plan to do on this side of the business is a whole host of small projects. So what we will do is we will do our desk study. We will look for areas that we think are beneficial or promising when it comes to the geology, but we're also understanding who the heat users are in those areas and whether we can partner with them. And so this becomes part of our exploration, Rubik Cube, modelling and so on. And so what we're doing there is when we drill to 2,000 metres, the water that you're going to bring up is hot. So remember earlier when I was talking about the geothermal gradient across Cornwall, it's very high. Hot water is perfect for a variety of different processes in the food and beverage industry in particular. So we're looking at breweries and dairies and so on. So what we're looking to do is to work with those kind of businesses locally, bring up this hot water, pass it through a heat exchanger so they can have the heat. This means that they'll be then using less natural gas for their heating processes, or less oil or so on. So they're decarbonising their business, and we can then take the lithium out. We can process that up, as well as potential other byproducts, and then the water can be returned to the subsurface back into different fracture zones. And so one project that we've recently announced is the company called Rodders, so they're a clotted cream company down here. We're looking to work with them to understand if we can help decarbonise their business and produce lithium. And we've also announced a project that we're looking to start with a company called iGas, who are interested in doing geothermal for district heating across the southwest. And so there's lots of interesting projects and exciting projects in that part of the business. And what we would hope to have is at least 10 to 15 sites across Cornwall, all with small processing plants, no bigger than a standard industrial unit, producing lithium chloride, which can then be sent to other companies in the UK for refining, or go to a central plant where it can be converted into lithium carbonate or lithium hydroxide, depending on what the industry requires at the time. So how we're going out about this, because there's no current geothermal production in the world really at a commercial scale, is we're doing a huge amount of investment into our direct lithium extraction, so our test work, and that's the work that I'm primarily involved in. And in order to do this, we approached the Cornwall LEP, so local government, and we were awarded a £4 million grant to produce and, design and commission a pilot plant in the UK by March of this year to help us with this direct lithium extraction. So we achieved that, which was great. In the process, we hired 10 full-time member of staff, which we've all retained since the project is finished. And this program has allowed us to trial a whole host of different technologies in Cornwall, using real waters, and allows us to rapidly increase our understanding of how these technologies work, with the aim of then rolling that out across a whole host of projects across the southwest. And so, yeah, that's really the power of government funding to allow us to do these demonstration plants in the right way. And so that was a bit of a convoluted update about how our projects are running, but I'm happy to answer questions on them in a second. But first, I thought it would just be good to kind of wrap up where Cornish Lithium are and where we're going. So Cornish Lithium, we are really focused on this responsible development. We want projects that have low footprint, low carbon impact. Our aim is to align our extraction, exploration and so on with the UN Sustainable Development Goals. And in order to do that, we have built out our ESG team, who are highly experienced in environmental monitoring, social and stakeholder engagement, and also bringing in good governance into the company. We, as I mentioned, have this ESG team to interact with the local communities. We do a huge amount of engagement on, well, across the Cornwall, but now across the UK as well, talking in schools about getting into geoscience, talking at parish council events about what we're going to be doing in those areas. We support a number of Cornish charities, including the Seal Sanctuary down here, and a couple of the nature trails near some of our sites. And all of this is to have a continued dialogue with the locals who are living here, but also to give back to the community and hopefully engage them in jobs either directly or indirectly. We are looking at using the latest and greatest technology, because both of our deposits are what we call unconventional deposits, in that it's not a spodumene, it's not a salar. And so in order to process them, we need slightly different tech, and we need to think outside the box. That's allowed us to trial a whole host of new techs, which are more energy efficient, more thermally efficient, lower footprint, and so on. And we're also working with people across the supply chain to understand how we can build the circular economy into our extraction, be this via processing battery recycled materials or other things. And finally, we want to be the foundation of a domestic supply of lithium in the UK. This feeds perfectly into the UK's recent strategic review on critical metals, and how we and the government hope to capture as much of that value chain as possible in order to keep as many jobs in the UK as possible. And ultimately, if we want the automotive industry to continue to be competitive across the UK, they need raw materials that have come from the UK, and they need to refine that material here and produce the batteries here. And we hope to be a small part of that. And so that's a kind of whistle-stop tour of what we've been doing in Cornwall. Bit convoluted, but I hope you enjoyed it, and I'm happy to answer any questions on the work that we're doing down here. So thank you very much.
Thanks very much, Rebecca. That was really interesting. Lots of insights into some exciting new developments going on there. Let's just see if we have some questions from our audience. Yeah, Austin. If just to say that I'm going to have to relay the questions to Rebecca through here, because she can't hear you through this. So just make sure that what you say is easy for me to repeat. Okay.
I can kind of hear you.
Are there not heaps of waste heaps that the mica can be extracted from with the China clay people have discarded?
Yeah, so the question is, can you reprocess the China clay waste materials? Like is there a lot of mica lying around on the ground in waste heaps from the China clay mining?
That is an excellent question.
Actually, are you mining bedrock?
That is an excellent question, and we actually have a government-funded project looking just at that. It's called CLIck, which is a very long acronym, but it's all about can you recover lithium from China clay waste. So what we've been doing is sampling the tailings from the old pits to look at the levels of mica and how that varies across those, and then putting that through our processing plant or setup. So it's something that we're really interested in understanding, and it's something that they do across the mining industry in a variety of other places when the cut-off grades have been lowered. So it's definitely on our radar.
That's great. Okay, thank you very much. Yes.
Are you allowed to go across the border into Devon and extract from round Dartmoor? Because I seem to remember lots of China clay, the White Alps, just north of Plymouth. So there was a China clay industry in South Devon. And I wondered whether that was on your radar.
But I have to take my passport when I cross over to Devon. But so when they let me
you go the way in then across from Cornwall into Devon, yeah.
yeah when I cross the river once on the blue moon, we are looking at exploration targets from a desk study level across the Cornwall and Devon because of the granite particularly. The problem, well, not problem, but the amount of mining data we have in that area is less than what we have in Cornwall, and so at the moment we're focusing on our kind of high priority targets. But yes, we do keep Devon in mind.
Okay, thank you very much. Yes. Yeah.
Make it simple. Just the feeling, the global feeling of economic growth and ecological collapse. I wonder what the local feeling is in that part of the world in terms of economic growth and ecological collapse.
Okay, so the question is, in the part of the world that you're working in, do you get a feel for the way in which essentially the public view this nexus, if you like, of economic growth and ecological collapse, which I think is, it's quite a topical issue in the news at the moment with what's going on economically.
Yeah, absolutely. So I think across Cornwall on a whole, there's quite high levels of what's known as social license to operate, so SLO, which is essentially how much do the locals like your idea. That goes down to the fact that for the most part, people here, either they were in the mining industry and they were here when it collapsed, or their parents were in the mining industry and they're here when they collapsed. So there is a lot of positivity behind our activities here, as well as those of other mining companies in the southwest. So Cornish Metals is a great example of that. And I think it's become even more important recently in Cornwall. Well, obviously the cost of living across the UK is extortionate and rising, every minute. But in Cornwall in particular, there's a significant housing crisis and huge levels of deprivation. So some of the most deprived areas in Europe can be found in Cornwall. So there's a real imperative to bring direct and indirect jobs into Cornwall that aren't seasonal. So that is the big impetus behind the support in the area.
Okay, thank you. I maybe pick up on something that you mentioned there, and because something that's been going on in this part of the world is local governments and the Geological Survey trying to resolve issues of fuel poverty around here. And one of the ways they're doing that is actually extracting hot water from mines, actually coal mines here. So is that an issue where you are? And do you think that the hot water extraction that you're doing can have a function in actually reducing social deprivation and poverty as opposed to, use in agriculture and industry and that kind of thing?
Yeah, so we're not targeting heat recovery from mines in the same way that they are in Glasgow, because our targets are significantly below the mine workings. So we'd be looking at 2 kilometres, and the deepest mine in Cornwall probably about 400 or 500 metres. So we're not interacting with that water, which means from an ecological point of view, that's far better, because you don't want to be producing mine water. But we are looking at working with a whole host of housing schemes across Cornwall who are looking to build new housing developments and want district heating to be part of that. And so if we can drill our boreholes, on the areas that they're going to be building, they can then build their district heating schemes around that and use the heat from the waters. So that would hopefully provide some housing with kind of an eco-friendly heating. And then also go back to that kind of decarbonisation of businesses as well. So we do hope that can be a significant kind of impact across the southwest.
Okay, great. Thank you very much. Any other questions from the floor? Yes.
I suppose the logical question would be, but I think you probably targeted Cornwall, also because it's probably the best target in your observation. You might be looking at some activity in Devon. Are there any other parts of the UK? And I suppose thinking of Scotland, in Scotland, where do you think there would be any potential for lithium extraction or lithium development in the future?
Okay, so the question now, I had a version of that question myself, which is that did you kind of start in Cornwall just because you knew that the region was rich in lithium, and that's been something that's well known for a long time? Or did you actually look more widely and home in on Cornwall because it had an advantage over some areas? How did you start, and how much more widely have you looked in the granites around the UK?
That's a great question. So I'll touch on the why Cornwall first. So actually it started with our CEO and someone telling him about a paper from 1864 that basically took a bunch of water from one of the mines. This water was pouring into a mine from a fracture, was taken up to London to a Professor Miller. I think he was at King's College. And he essentially wrote a paper in 1864 that said, there's lithium in this water and we have no use for lithium because it's 1864. And someone told him about this paper and he was like, that's an opportunity. And so that's where the company started, at least on the geothermal side. And then a year or two into the company being founded, someone told him, oh, did you hear that, during World War II, they were mining for lithium from St. Austell for, it's used as a scrubber in nuclear submarines in the air recirculation units or something. And that's where our hard rock project started from. So to say that it was a geological reason is by the by. But subsequent to that, we have done our due diligence. So Cornish Lithium, when I actually joined as part of this government program called Li4 UK. So it was part of the Faraday Battery Challenge. And this was all about evaluating different lithium targets across the UK, so Northern Ireland, Wales, Scotland, and so on. And the UK has a few other areas that could be prospective. Cornwall is the most prospective because of the granite. But in terms of geothermal waters, there's potential up in the kind of Durham, Weardale area. And there are 2 companies up there looking for lithium as we speak. And there are a couple of areas in Scotland that have known mineralization of lithium. They are in SSIs, so sites of scientific interest.
Oops.
So so they aren't, how extensive those lithium deposits are is unknown, and also they are in areas that you won't be touching anytime soon. So for now we're Cornish Lithium and focusing on Cornwall.
Okie dokie. And would you then, in terms of a sort of wider exploration strategy, look for example, S-type granites or particular types of granites, maybe the Weardale one, something like that? Is that the kind of thing that's producing all this lithium?
So that's a good question. It seems a bit more complex than that. There's only 5 lithium enriched granites worldwide as defined by the USGS.
Wow.
And so it doesn't seem to just be, there's an S-type granite or it's an I-type granite. It seems to have been something that was very specific when this granite was actually formed. And that is a question outside my ability to answer right now. I can ask the geos tomorrow. But yeah, so there's a couple of the granites in China and one of them in Europe, I think, as well, that have this particular lithium enrichment. So it's not seen in every granite at all.
That's intriguing. Okay. So any other questions?
It's the lithium. Does it come from the feldspar?
Yeah, it's with the source of lithium is mainly in the micas, is it?
That's my favorite question at the moment,
Good.
because I'm trying to figure that out. So papers written on the granites and so on in Cornwall say, you know, the micas are the reason that there is lithium in the water, because micas break down and they release the lithium, and then, you know, lithium is very soluble, so it gets into the water and it's all very happy there. But then when you go up to St Austell, where we're looking for lithium in the hard rock, that granite has been altered, but the micas are there and the micas aren't altered. So it's a really good question. I think that it's a combination of the two, where in some areas you are getting mica breakdown, but by volume, the plagioclase is the biggest, biggest amount of the granite body. So in order to look at this, we're doing a lot of R&I projects with different universities across the UK, including some up north, to look at water rock interaction experiments. So breaking down rocks with water at different pressures and different temperatures and under different conditions to see how all the minerals evolve with time. And then also looking at the fractures themselves and the rocks themselves to understand the distribution of alteration across different areas. So yeah, there's lots of different theories about where the lithiums come from. And it's probably a combination of everything, because geology is not black and white.
Yep, I'll never get a straight answer out of a geologist.
No.
What about pegmatites? You get that down there?
Yeah, that's what I was just thinking about as you were saying that. So, I mean, this area is well known for its exotic pegmatites, and what is these strange things called? Is it luxulionite and that sort of thing? Metasomatism and sort of rock alteration. So, are your best concentrations of the lithium resource localized to particular zones of alteration, or is this just a general feature of the granite right the way through? Obviously, St Austell's got a lot of hydrothermal alteration, hasn't it?
Yeah, so the granite grade is very low because you're mining it out as a bulk, so it's only at 0.1%. So yeah. The micas themselves have about 20,000 parts per million lithium, or can have up to that. So it's quite a significant percentage of the lithium. The micas are a small percentage of the granite. There are pegmatites around Cornwall that have kind of shot off the granite bodies, but they're not wide enough to mine in any sense, but they do have higher lithium grades. And that's kind of what you see in Australia with the spodumene. They're all pegmatite deposits. So yes, there are some areas that have much higher lithium grades, but they're not extensive enough to focus on mining.
Okay.
You also get boron tourmaline.
Yeah, so they're often rich in tourmaline, these ones, aren't they? They're boron enriched as well. Yeah.
So most of the granites in Cornwall have a lot of tourmaline, and in Cornwall as well. Another unanswered geological question is, where did all the boron come from? Because there's far too much boron in the system, because everything's been altered by tourmaline or to tourmaline. So yeah, it's an interesting problem for the geologists.
It's the same in the Himalayan granites, but I can't see us mining lithium in the Himalayas yet anyway. So yes.
Yeah, do we know where the lithium is in the structure of the minerals, for example? Would it substitute for potassium?
Okay, we're getting down to the atomic level now. So.
Oh, crikey.
Yeah, so lithium substitutes into micas, but what's just for the non-mineralogists, the non-mineral geeks around here? What's the main substitution of lithium? Is it for the potassium in the micas? I guess it is.
Oh, I mean, I'd have to Google it. But I think,
well, you have the advantage of being able to sit there and do that. So.
Yeah, that's what I'm doing right now. Because I don't look at the rocks anymore. I just look at my emails. So yeah, no, I think it is. I think it is, but I will check and I will get back to you.
Okay, that'd be good. Right, we've all got to Google lithium substitution in micas this evening.
You want to look at lepidolite and zimwaldite.
Lepidolite and zimwaldite are the ones. That's right. Yes.
So it goes into the potassium.
Uh-huh. Okay, thanks for that, Jim. We've got a bit of real-time research going on here, which is great. So I think we've got time for a couple more questions before we finish. Okay.
Is she sure? Isn't it a surety about battery technology for the future. There are other projects like nuclear fission and things like this that are going on. So, and the transportation may change. Air transportation instead of using the road transportation. It's futuristic things.
Yeah, so that,
It is coming out of America. There are things in America that I'm sure that are being created there.
yeah. So this question is really about the kind of timescale that's envisaged for energy packages that use lithium, and particularly if you have geological extraction mining type projects which have quite a lot of lead time, with the technology for energy storage and energy use changing so rapidly. Is there any concern that you might kind of get left behind and things will move on beyond lithium? I mean, lithium's been an important part of batteries for a long time, hasn't it? So,
well, the lithium battery has only been commercialized in 1991. So the lithium battery is as old as I am, but it's only really been in the last 10 years that people have started thinking about putting it in cars. So on the energy side for electric vehicles, you've got hydrogen, and that has its own setbacks, particularly producing it, period, storing it, and then also transporting it. And car manufacturers are focusing pretty much solely on lithium now, and that means that it's pretty much tied into the car market for at least 2 decades, because that's how long it takes for them to design and manufacture their cars and stuff. So I can't see lithium being replaced in the electric vehicle world at all, really. Sodium batteries could be used as energy storage instead of lithium batteries, so where size and power to weight is less important. Sodium is obviously easier to get hold of because you can just process it from seawater. That needs a bit more R&D, but there is potential for some replacement there, as well as second life lithium batteries going into energy storage. I heard someone mention nuclear fusion, or which is something that we also looking at and working closely with people in that industry. They need lithium-6. So the number of times I've been asked, can you get me lithium-6 by someone in the nuclear fusion industry, I would be rich if I counted the number of times I've been asked that. So yeah, so exactly. So there will be a need for lithium in that industry, obviously in smaller amounts than the battery industry, but it would come at a significant premium. So from an economic point of view, it would also make sense to mine it. You just need to fractionate the lithium-6 from the lithium-7.
yes.
So it's a minor problem.
That'll be some centrifuge.
Yeah, exactly. So yeah, there are other technologies on the horizon, and but given where lithium sits in the periodic table, it's not going to be beaten on its kind of charge density. So people will need lithium.
Right, that's interesting, and that was a kind of unexpected connection to the question, which is that for fusion, lithium might actually have a role in there too. We had a hydrogen-powered sports car at UWS over at Hamilton just before I left, and the guy who built it said that you can't drive it on the road unless he informs the fire brigade first. And so if it's ever to become commercial and Granny wants to go to Tesco in her hydrogen-powered runabout, she has to ring up the fire station to get an escort to Tesco's for going there. So, okay, I'm going off the subject here now. So okay, Ian.
One more question. You mentioned the byproducts of processing lithium, cesium and potash. Do they play any important part in the business, or in the strictly striving for a carbon zero? Do they play any part in the game at all?
So this is about the metal byproducts like rubidium, cesium, and that sort of thing. So you mentioned that they can help to improve the economics. So do you have markets? Is there a sort of supply chain there? And do they play a role in this decarbonation like the lithium does to such an extent?
Another great question. So potash is great for fertilizers. So that industry is well developed, and so there's a big market there. Aggregate, obviously great for building things, and then the rubidium and cesium are both very niche markets, but they are critical to the UK's defence. So cesium is satellites, so your atomic clocks. Rubidium's used in things like night vision goggles and things like this. And cesium, there is currently one producing mine in the world, because one of them shut down.
Wow.
So, and then, rubidium as well is very similar. So things like that, whilst they would be very small markets, they have a huge importance to the UK government. And so the products, have a premium, and that's what helps them. But I mean, our projects, particularly the hard rock project, is economic without those byproducts, and the initial resource has been done without those values included in it. They're almost added bonuses, really.
Okie dokie. I'm just going to finish off with one question, which is that you had a kind of mantra in there that if you can't grow it, you have to mine it. And you were talking about the energy transition, but there also presumably needs to be a materials transition where we move as much as we can from mining primary resources to recycling resources and keeping them in the supply chain without having to mine anymore. So with lithium, we're right at the beginning of that process, really, aren't we? We have to get stuff out of the ground. But is anybody yet modeling what the future is like? To what extent is lithium recyclable from the batteries, and to what extent can there be a transition from a lot of mining to less mining and more recycling?
Another great question. So the World Bank group did a report a year or two ago about critical metals and looking at circular economy and all sorts. With lithium, by 2050, they're projecting that only 3% of the lithium required will have come from recycled resources. That's because the demand for lithium 10 years ago was so minimal, and it was predominantly greases and ceramics and so on, and this industry is basically grown out of nowhere. So you've got to build up that supply. I think that we're talking 500% increase in demand in lithium in the next 20, 30, 40 years. And then you've got to have time for the lithium batteries to come through. So the problem that battery recyclers are facing at the moment in terms of R&D is that electric vehicles, their car batteries are lasting longer than they thought they would, which is great if the person who owns a Nissan Leaf, who bought theirs in the early 2000s. But it's bad for battery recycling, because they were hoping to be producing more recycled lithium, and then they can't. They're still driving around. So there's still a lot of tech and R&D going into that battery recycling step. Separating certain parts of the batteries from each other are quite easy, but getting things like the cobalt and nickel to separate are a big issue. Lithium does behave a lot different to those kind of transition metals, and we've had some success working with companies who are looking at doing battery recycling. So we've been giving them raw lithium, they've been making little batteries from it, and then they've been recycling that battery and then making another one from the thing. So that's one R&D project I've got going on at the moment. So yeah, you will have a circular economy in there, even if it's pushed by government legislation, because they'll make car manufacturers responsible for the end of life of their vehicles. But you need that raw material to begin with, and we're nowhere near kind of there yet for the lithium, at least.
Okay, thanks very much. Thank you. So you've done a great job fielding all these questions at such a remote distance. So it's been really interesting to listen to. But Ian Miller now will give a vote of thanks. So thank you very much.
Right, okay. Well, Rebecca, thank you very much for well, I certainly found a very interesting talk on, I suppose, the element of the age. Great importance, considering Glasgow was the host of COP26 last year, and it's good to see what is being done to try and decarbonise our society. I found it particularly interesting that we can go back to old mining areas and find materials which were discarded in the past. And it's not always done by geological methods, but by someone making a comment about some report from the last century. So history comes into that. Also very interesting, the way that the whole process is being made as sustainable as possible and of real value, not just to the UK and to possible industries that will stem from the battery business, but also being good neighbours to the county that's going to host your activities. Certainly look with great interest to see how Cornish Lithium progresses in the future, and I think that's probably enough for me, and thank you very, very much, and thanks for fielding all those great questions, and I'd like to think that the Society will show its appreciation in the normal way. Thank you very much.
Thank you for inviting me. Thanks.
Can I just add my thanks to you, Rebecca, just to let you know that Ian will be in touch with you to send you a gratuity. We like to give our speakers a bit of souvenir from Scotland, so you can either choose between a nice malt whiskey, a Scottish gin, or if you're not a drinker, you can have an electronic book token. But Ian will be in touch with you to your choice. But yeah, thanks very much indeed for being here. We almost felt you were here tonight. I think it's just the first time we've tried a sort of a Zoom lecture where there isn't a Zoom audience but a live audience with a Zoom speaker, and I think it worked tonight. And I think and I appreciate the fact that you joined in our experiment and made it such a success tonight. And we look forward. I think all of us will end up watching the recording next week as well, because I think there was so much in there, and it set all our minds thinking about the future. And it's good to see positivity in this crazy world, and that there is a sort of a way forward with this. So thanks again from me.
Well, thank you for inviting me, and if anyone has any questions that pop up in their brains in the next couple of weeks, don't hesitate to shoot me.
Yeah, we might. We will send the recording link out to our membership, and we'll ask them if once they've seen it whether they have questions, and Ian I think will compile, rather than bombard you with hundreds of emails. I'm sure your inbox is as full as you don't want it any fuller, but we'll try and compile it and sort of sort it into sort of sensible questions that we can then publish on our website, well, send out to our members, so that we can have we won't keep the dialogue going for a long time, but I think it'd be nice for the recording people listening to the recording to sort of have and they'll have heard the Q&A. We've recorded the Q&A as well, so hopefully that will field some of the questions that people, but I'm sure watching it again, your people will come up with, like I keep thinking about why lithium, there's this question about why is a lithium in these very rare granites? Where does it come from? Why haven't we got any? How much spodumene do we have in Britain? Do we have any? Why not? Yes. So yes, good questions and lots of intrigue for us to think about. Thank you again. Leave now and go and have a well-earned drink and relax. Thanks again for giving up your evening.
No, thank you for having me.
We're going to end the meeting now. Thanks a million.
Bye now.
Bye.
Okay. Bye.
Bye.